everyone, welcome back to Python Code Nemesis. In this video, we'll explore multithreading in Python. Multithreading is a powerful concept in computer science that allows programs to execute multiple threads, smaller units of a process, concurrently within a single process. This means that a program can perform multiple tasks at the same time, improving efficiency and responsiveness. In this article, we will delve into the world of multithreading using Python, a versatile programming language known for its ease of use and robust standard library. Understanding multithreading. In traditional programming, tasks are executed sequentially. If a task takes a significant amount of time to complete, it might lead to delays and reduced performance. Multithreading addresses this by breaking down a program into smaller threads, each handling a specific task. These threads can run concurrently on different CPU cores, enabling faster execution and better resource utilization. Python's threading module provides a simple way to work with threads. Keep in mind that Python's global interpreter lock restricts the execution of multiple threads in a single process, so multithreading might not fully utilize multiple cores in CPU-bound tasks. However, it's still effective for I/O-bound tasks where threads spend time waiting for external resources. Here's an example. Let's consider a scenario where we need to download images from multiple URLs. This is an ideal use case for multithreading, as downloading involves waiting for external resources. Before we begin, you need to have Python on your system. This is the code. So we first import the necessary modules: threading for working with threads, requests for making HTTP requests, PIL for handling images, and bytes.io for working with binary data. We define a list of image URLs that we want to download. The download image function takes the URL as an argument and downloads the image using the requests.get and saves it to disk using the image class from PIL. Now we create thread objects for each image URL. The target parameter specifies the function to be executed in the thread, and the args parameter provides the function's arguments. We start each thread using the start method. So you can see here, we start each thread using the start method. We wait for all threads to finish using the join method, which is here. This ensures that the main program waits for all threads to complete before proceeding. After all threads are finished, we complete this task and we print a completion message. To run this example, you save the example in a Python file, install the required packages with pip install requests and below, and then run the script using whatever name you save it as. So that was it for multithreading. That can significantly improve the performance of I/O-bound tasks while allowing concurrent execution of threads within a single process. While the global interpreter lock restricts the full utilization of multiple CPU cores for CPU-bound tasks, multithreading remains a valuable technique for responsive and efficient I/O-bound operations. That's it for this video. Thanks for watching. Please feel free to leave your questions in the comments. I will be talking more about multi-threading, and we'll be looking at some more examples in detail. Thanks for watching. Have a great day. See you in the next one.